Alright, so today is the day. We're going to be proving, deriving, whatever you want to call it, the Pythagorean theorem. So basically, I guess the first things first, we should probably be drawing a right triangle, since that's what we use the Pythagorean theorem for. So let's see here. I'm going to draw a triangle right here. It's going to be a right triangle. It's going to be epic, right? So a right triangle right here, right? And I'm going to call this side, let's say I'm going to call this side A. I'm going to call this side B. I'll call this side C, and right angle for right triangle. Now what I'm gonna do something interesting. I'm gonna hit a Control C, Control V 4 times, right? I'm gonna copy this triangle and paste it in a different orientation, I think right here. So I'm gonna draw another triangle like this. That should be good, I think. I'm trying to get the dimensions correct, so it actually looks like what I want it to look like. So let's see, there's another triangle right here. It's basically Control C, Control V, I just rotated it. So this is our right angle now. And let's see here, since it's the same triangle, just rotated. This is A, this is B, and this is still C. Alright. Now I'm gonna hit Control C, Control V again. And I'm gonna paste the right triangle, this same right triangle, but in this orientation. So like this. Right? I think this should be, I'm trying to match the dimensions right now. I think this should be good, right? Now I'm gonna connect the stuff. That looks about right. So same right triangle, this is our right angle. This is short side, this is A. And kind of longer side, this is B. And the longest side hypotenuse, this is C. Now I'm gonna finish off my drawing by drawing, well, we got another right triangle. I'm gonna paste the right triangle for the fourth time. So let's see here, how should I do this? I think what I'm gonna do it like this, right? So you see I'm being very artistic right here. And I'll extend this right triangle a bit and finish my drawing like this, right? This is my fourth right angle. So this is the hypotenuse of this triangle. So we have C. This is our short side. So we have A. And this is our kind of longer side. So we have B. So I don't know how good of a drawing this is. I think I'll make the drawing a little better real quick by shaving some sides off. So I think this should be kind of good. Alright, so basically what we have here is we have a square inside of a square. Now how do I know that? You see, if I call this angle theta, right? If I call this angle theta, no, you can't see that at all. I'll just get rid of that angle. We don't need it. But if I call this angle theta, this angle is going to be 90 minus theta. And this angle is what we have right here. So we have, and this is a straight line right here. So we have theta plus 90 minus theta plus this angle right here, we need to figure that out, plus some angle alpha, I'll call that. It's gonna all add up to 180 degrees. So I mean theta here cancel out. We get 90 plus theta, 90 plus alpha is equal to 180 degrees. And we get alpha is equal to 90 degrees, right? So this is a right angle too, and that means this must be a right angle by same logic. This must be a right angle, and this must be a right angle. Okay. So hopefully you can see all this. Yep. So let's see here. We have let's see here, 4 right angles on our entire structure right here. We have 4 right angles, and all the sides are the same. We have the side lengths are all A plus B, right? So we have a square here on the outside. Now on the inside we have 4 right angles. All the sides are the same. They're all C. So we have a square on the inside. So what I'm gonna do now, I'm gonna do something interesting. I'm gonna compare. Actually, no, I'm not gonna compare. I'm gonna find the area of this inside square in terms of A and B. So how are we going to do that? Well, basically, we'll find the area of the outside square, right? And then just subtract out the areas, like the combined areas of all the triangles we have. So basically, yeah, let's just do that. So our area of our inside square, which is C squared, right, is going to be equal to the area of our outside square. So side length squared, so A plus B squared, right? And minus the area, minus the combined areas of all our triangles. So let's see here. We have 4 triangles, right? What's the area of each triangle? Let's see here. 1/2 base times height. So in this case, it's going to be 1/2 A times B. So minus 1/2 A times B. Alright, so maybe I think I'm going to simplify this a little bit. So I'm going to get c squared is equal to a plus b all that's squared. Oh, we know that. This is a squared plus 2ab plus b squared. Minus 4 times 1 half ab. Let's see here. 4 times 1. That's 2. So minus 2ab. I see here 2ab right here plus 2ab minus 2ab. They cancel out. We get the ultimate theorem of all time. We get that c squared is equal to a squared plus b squared, i.e. the Pythagorean theorem. So guys, this is a pretty cool proof, and hopefully you remember this. So follow for more stuff like this.